Hello everyone, this is Gülşen and I will be representing Hitsoft R&D Center team, and I will be explaining HI-Terra solution which is developed via Grow Soil Conditions dataset. And our participants are Bülent Gülşen, it's me, and Umut Ersin as a group, and also our mentor is Andrew Cobley. And so, who is Hitsoft? We are basically on the sector almost more than 10 years, and since 2019, we started our R&D center processes, and also we completed already lots of machine learning and deep learning projects and ongoing as well. So, about Grow dataset. So there are sensors, weather, soil, moisture, data, but also we need some model and forecast why and also how. We will explain this. So our journey ends up with HI-Terra, which is an intelligent infrastructure for soil moisture forecasts, which helps to minimize artificial watering and takes the advantage of machine learning and deep learning technology in agricultural practices. And also it is able to create dynamic forecasts on real-time parameters and warning system for important weather and critical water level conditions. So it's a basic mock-up that you can see in here and shows soil moisture for the users, but also it's applicable to any type of platform. So objectives of HI-Terra is modeling soil moisture, forecast soil moisture, and when to water, to tell when to water. So dynamic learning mechanism and intelligent infrastructure using LSTM, which will be explained later on. And also it boosts data-driven agricultural processes and crop health, also societal impact and SDG tackling that we need to achieve a sustainable solution. So our current stage of development is basically TRL 3 that you can see in here. We analyze the conditions and also through basic principles, idea creation, dataset selection, and new dataset researches. And then we normalize pre-processed and extracted features of Grow dataset, and also weather data integration that we collected the dataset of dark sky. Also, we defined our market and also user groups. And finally, we applied deep learning using LSTM model, train and test, and also soil moisture and weekly, and then application scenarios and evaluation potential. So what is HI-Terra? It's basically takes Grow sensor dataset data and also weather data, merge them and also analyze them through LSTM model, which takes train and test steps and also performs model to understand and also forecast soil moisture. So it tells people and users to take smart decisions about water use, soil moisture, and optimization, also smart watering through the system, mobile, web, or any API that we can consider. So it's a brief show up, and also we can see our methodology in here. So it takes its characteristics with deep learning algorithms since the beginning. So it's a structure of human brain. Basically, it replicates the system as well. So it takes conclusions like human and analyze data with logical structure. And LSTM model is an architecture. It's a special kind of recurrent neural networks, RNN, we can say, and capable of learning long-term dependencies. So here we can see data sets, Grow and dark sky, and our feature, which are more relevant that we could understand and also analyze the data. So here you can see the pre-process steps which is the chunks that we can see here. We divided into chunks because when we visualize data, there were some gaps and some of them were a little bit challenging data. So we take them as chunks, and also you can see the zoom view of one of the chunks in here. So we pre-processed and then move forward to model the data set. And here you can see LSTM modeling, which takes predictions through the LSTM network, and then the prediction comes as a feature and predicts more and more. So it learns and also generates predictions iteratively. And then the experiment setup comes. So it's a train and test period, which takes the data as a train and test, and also it splits into two. Then, so it's also needs to tell that there are 100 hours to train and test period that we observed in here. And also we performed in this way to make it intelligent and learning mechanism. So after the model learned, we were able to develop, generate two 24-hour periodic forecasts with the MAPE score of 7.5%. So it's basically a high range at the beginning, but we will improve, of course. So you can see in here, the blue one is the actual one, and the green and yellow ones are 24-hour data, so forecasts. So you can see in here 24-hour and then 24-hour it comes, and highly merging model that we can see in here. And the other one is, for example, in this way, as you can see, and here you can see the main data that you can that are merging together mostly. So let's see our users and beneficiaries. Our user groups are farmers, landowners, greenhouse owners, which are basic end users, and also our customers maybe. So also the golf course owners are very crucial point, because the golf courses are taking millions of tons of water yearly. So sometimes it's hand watering. So it's the same with the greenhouse farm fields and so on. So it's both very important for people to optimize and also reduce water use, and also cutting costs. And municipalities, water resource departments of governments and utility companies, so they are important actors to water management systems, and also optimize and secure resources for future. So also beneficiaries, we can see academicians, researchers, and society. Academicians and researchers can enhance their scientific researches with HI-Terra, but also society will be beneficiary here. So they are both in water resource part and also food chain, and we can consider the new jobs for societal aspect. So here we are in the middle of 2-3 markets: machine learning, which is deep learning together, but we will take deep learning in here, and smart agriculture and agriculture analytics. As you can see, deep learning takes a huge peak by 2022, reaching almost $9 billion, and also smart agriculture applications, and also agriculture analytics that are quite high growth rate and size. So our use cases will be greenhouses, fields, and golf courses, of course, to optimize water at the beginning, because it's crucial, and also it's very sensitive system in greenhouses, and fields can lose lots of moisture by weather conditions, and they are open to any changes in the system. And also golf courses includes some automatic or hand watering system. So it's important to reduce water use and cut the excess costs in this way. Advantages that we can see here, the model is actually able to learn by more data and more training activities. So it's possible to learn iteratively by time and make predictions with high accuracy. So it's scalable and expandable from technological, market application and user parts as an infrastructure for multiple use cases. Monitor soil moisture and watering periods, and also save water by forecasts through a sustainable dimension, which tackles also climate change. That you can see here, the SDGs we touch. Sustainability dimension of HI-Terra takes its society part, economic part, and environmental part with technology, and also its market applications, which is very wide to apply. And what is next? So we will improve model, we will improve accuracy, we will apply more data such as soil type dataset and also properties, forecast how much water to be used, which will be very critical, and consolidate users and market to achieve measurable impacts and results. And also it will be like here, and it will be generating integration even more. So you can see here how it's supposed to look in our mind and in the real world, hopefully. So thank you very much for your attention, and thank you for the opportunity for this exciting experience. Thank you so much.